live.
Good afternoon, everybody. Welcome to the Space for 5G webinar. This is the 6th episode of a series called Space for Twin Cities that we started in November 2020. And today we're going to discover how the integration of space capabilities in 5G brings opportunities for people, businesses, and a whole range of other organizations. Applications consist of examples such as drone delivery, self-driving vehicles, optimization of cargo logistics, augmented reality, a whole range of different domains. The experts presenting these sorts of issues and opportunities today are Stefano Cioni, who's a telecom systems engineer, Florin Catalan-Grec, who's in the GNSS area. He's a GNSS strategy engineer, and Antonio Frank, who's head of future program acquisition, satellite constellations, 5G and AI. I'd like to proceed to the actual content of this as quickly as possible. So without more ado, I would like to start. The first presentation will be a joint presentation by Stefano and Florin, and I would like you to think about the following questions. Both of you are representing the ESA task force. Which are the current achievements in the field of fifth generation 5G? And looking to the future, which are the R&D activities revolving around 5G positioning on this side. So please, Stefano and Florin, the floor is yours.
Yeah, thank you very much, Gordon, for the kind introduction, and welcome to everybody. Concerning your question, yes, for sure, in the next 20 minutes, my colleague Florin and I are going shortly to debrief on our virtual connected attendees on the latest achievements in the space ecosystem about 5G. As we are showing here also in the logo of today's event, the satellite is out there flying over our cities and all over the world. Thus, space system and space communication are ready to be part of the 5G arena. So in this slide, I guess you are all familiar with this kind of picture highlighting how fast the cellular technology is growing and how rapidly we are getting used to have more and more capacity, in particular in terms of available data rate. But 5G is something more, is opening a new paradigm. 5G is a network of networks, is a wide network bringing together the new market, or also known as new verticals. You can read below, in fact, that 5G is promising new features and capabilities as very fast and reliable communication, localization services, and for instance, my colleague Florin will discuss about that later on. Connectivity to cars for autonomous driving, very important, smart cities, that is the topic of today. And last but not least, is introducing for the first time ever the satellite component, the satellite communication component. And of course, you can imagine we are very, very happy for that. Next slide, please. And for whom are not familiar with the 3GPP standardization forum, here I'm showing the three main pillars: SA, service and system aspect; RAN, radio access network; and CT, core network and terminals. All of them are then divided in a specific working group. Nevertheless, here the message is that altogether they are in charge of defining the 5G standards, as they did in the past 3G and 4G technology as well. For completeness, I'm showing in red the working groups where ESA and our experts are mainly involved and contributing with technical document for space and 5G. Next slide, please. And an important question, how do we get in 3GPP? Here, I very shortly reported key milestone in which ESA and our satellite industries have been instrumental to promote and to support space in the 5G standardization process. You can go through all of them, and I'm just here to want to remark, and let me just report a few of them. Of course, the start, the first standardization meeting. It was in September 2016, a big shock for us, and an electrifying experience as well, because it was really impressive, the amount of person and discussion in a full week meeting. Immediately after, in March 2017, the first study phase for non-terrestrial network and high accuracy techniques. Moving on, we have achieved to add Galileo. Exactly this slide. Moving on, we have achieved to add Galileo in the 3GPP specification for assisted GNSS solution. And finally, just let me jump to last year, to 2019, where we have got very great result. The first ever measurement and performance result on GNSS, Galileo plus 5G, and ultimately in December 2019, the first ever work item on satellite communication, with the aim to specify and to adapt 5G technology to space. Really amazing, I would say. Next slide. And here where we are. This is 5G release 17 timeline. And you can see that in a year from now, we will freeze the new specification, including the satellite component. Recalling the previously presented 3GPP organization, you can see that there are very important and strategic activities in all three pillars. And this testify very well how SATCOM and GNSS enhancement are rooted in the 5G roadmap. Let me emphasize one more time. This has been achieved thanks to our ESA engineers and managers, which supported and promoted space since 2018. And along with the future-looking vision of several European and Canadian space industry and research institutes, which have technically demonstrated the interest and the feasibility of a 5G satellite component. Next slide, please. Let me now spend a few technical words about the satellite architecture opportunities in this Release 17. I am summarizing the entire complex 5G system in essentially three logical blocks. User equipment in green, the base station or G-Node B in blue, and the core network in red. And now the question, where the satellite could be placed? In the top left picture, a transparent satellite, so just a mirror, is enabling the direct connectivity among 5G terminals and the terrestrial base station. Important, as shown, as 5G terminals is intended either a smartphone or a mobile platform equipped with a dish or a phased array antenna, so in order to cover multiple and diversified market opportunities. Of course, this is a very appealing case and probably the most juicy one. However, for our space sector, don't forget that also the pure transport case or the backhauling scenario, top down, will also be supported. And this, the satellite And here, sorry, the satellite is giving the connectivity among a base station and the core network. Next slide, please. And this is the last one before passing the token to my friend Florin. And here I'm reporting what are the expected performance via satellite. Here today is, of course, reported the today answer, today expectation based on the current technologies. Nevertheless, we know that technologies improve rapidly. And moreover, as engineers, we should always thinking out of the box and giving our contribution to go beyond the current limitation. Actually, concerning R&D opportunities and pre-standard prototyping developments within ESA funding scheme, my colleague Antonio will certainly cover this aspect in a couple of minutes. Anyhow, coming back to the 5G satellite performance, you can read that a couple of megabits per second is the target for handheld devices in order to complement the extreme coverage for our personal connectivity. Then increasing the terminal form factor, it is evident that tens and hundreds of megabits per second become really possible also via satellite. Last but not least, the IoT machine-to-machine market. Here, the data rate is not the driving factor. However, it is a coverage. Therefore, space can really play an important role. Thank you very much. Florin, the floor is yours.
Thank you, Stefano. Good evening, everyone. And thank you for the invitation to this event. Today, I'm here to talk to you about synergies between satellite navigation and 5G, and to introduce the navigation directorate strategy with respect to these two technologies. We could move to the next slide, please. Let me start first with few general remarks on the current 5G landscape. So this ecosystem has evolved a lot over the last years, and besides the traditional players that we can see on the left-hand side, it now includes a growing presence of satellite industry and space agencies, which are convinced of the potential for an integrated satellite and terrestrial network in the context of 5G. And just one final remark before moving to the next slide. When I refer to the satellite component from now on, I mean the satellite navigation, while Antonio will deal with telecommunications aspects in the next presentation. We can move to the next slide. So from the very beginning of this presentation, we should now know that 5G is much more than a standard for higher data rates. And among many new capabilities, it can also act as a positioning system. Traditionally speaking, network-based positioning has not been very ambitious, and it has been always limited by the 50-meter positioning accuracy required by FCC E911 mandate in US. But this is no longer the case, and in a matter of few years, the ambitions change in a disruptive mode. And we can see that today the requirement in the latest release of 5G is to achieve performance better than 1 meter, regardless of the operational environment, indoor, outdoor. And here, from our point of view, we think the solution is to, for user, is to adopt a combination of GNSS and 5G, of course, in outdoor where GNSS is available. We can move to the next slide. So I would like to spend a bit more time to explain maybe what it seems to be an abstract idea of combining GNSS and 5G. So for a moment, imagine that your autonomous driving vehicle is driving in downtown of a big city, and because of the buildings around you, these signals coming from the GNSS satellite are blocked, and a large number of the satellites is no longer visible. So in this situation, you'd be very happy to be able to leverage on the 5G infrastructure to augment the let's say reduce and limited GNSS availability. On the other hand, it's also very important to point out that 5G alone as a positioning system may not always work with the desired performance, and it needs also to be augmented with GNSS and inertial sensors, cameras, and so on. The takeaway here is that everyone benefits the most when using both GNSS and 5G and not just one of them. We can move to the next slide, please. Okay. I'd like to spend also a bit of time to discuss a bit and to present the strategy that we follow when we deal with GNSS 5G integration. And this can be summarized in a loop made of 4 pillars, starting first with our active contribution to 3GPP standardization that has been already explained in details by Stefano. I'd just like to add here that we gain from this participation to 3GPP a lot of understanding into emerging use cases from a very early phase. And then we also have, of course, the opportunity to promote how GNSS, but not only GNSS, also satellite in general, can contribute to one solution to meet these emerging use cases. These inputs from 3GPP, then we convert them into R&D roadmaps, which we implement together with space, but also very important, we managed to attract non-space European industry in some of our projects, and I have put there two examples on the bottom. We also collaborate and coordinate very closely with the European GNSS Agency and with the European Commission, which are key stakeholders of the Galileo program. And they also have interest in seeing Galileo differentiators being promoted and adopted in the communication standards of the future. And lastly, we aggregate all these inputs from these previous pillars into the evolution of Galileo program and in general into our work on space infrastructure for satellite navigation. So I would like to elaborate more on these R&D opportunities and to circle back to your question, Gordon, from the beginning, what we can do in the coming future here. So if we can go to the next slide. We have recently opened a thematic call in the element 2 of ESA's Navis program. And here we are soliciting for proposal for co-funded R&D across the whole 5G positioning domain. So we are seeking for technology and products at high TRL level and even pre-operational phases across the whole 5G GNSS area, and we are focused on addressing needs from 3 main applications which are central to 5G technology. So the first one is the fourth industrial evolution, the industrial IoT or smart manufacturing. The second application we are dealing with is critical applications, drone delivery, autonomous driving. And lastly, a topic not very much advertised, which is timing synchronization. And this call for ideas is open until the end of this month, has been open in October 2020. So I encourage all our viewers that may be interested in participating to hurry up and submit for the beginning a very short outline proposal before the deadline expires. And we can go to the next slide. I would like also to briefly touch on the future. So as telecom industry is currently in the process of rolling 5G technology across the globe, the research community and the academia already begun the development of beyond 5G solutions. Let's say we can already call it 6G or 2030 era. At this moment is not yet clear, of course it's too early, what 6G will entail, but we believe that space infrastructure will continue on this uptrend started in 5G when satellite communication joined GNSS as the other space component of the global communications standard. So for example, personally, I can easily imagine a scenario where satellites will offer both communications and navigation services with 5G signals from platforms in LEO orbits. And we are very fortunate at ESA to have all the necessary skills and a strong team with engineers from technical directorate, from telecommunications and from navigation can easily turn any crazy idea into reality. So we are looking forward to unlock the full potential of beyond 5G in the near future. We can move to the last slide of my intervention. So I would just like to summarize briefly the main key messages of our joint presentation. So first, having been involved directly into standardization of 5G and having seen the applications emerging, we are confident that multi-GNSS will continue to be a key positioning, navigation, and timing technology also in the context of the most demanding 5G applications. Besides GNSS, satellite communication is catching up fast, and it will play a very important role in current and future global communication standards. And lastly, I think now it's the right time to begin preparing an ESA vision on 6G revolving around communication and navigation services from LEO satellites. Why not thinking about including Earth observation products, maybe in support of digital twin models and many other ideas that we can think about. So that was all from my side, and thank you again for having me at this event.
Thank you very much, Stefano and Florin, for that comprehensive overview of the technologies enabling the market opportunities, and also for the forward view in terms of where we're going. And I'm sure digital twin developments will be one area in particular where we'll be seeing a lot of interesting expansion over the coming years. The next intervention is from Antonio Franchi. And Antonio, we would like you to give us, if you can, to the extent possible in the time, if you could provide an overview of the 5G economy, in particular, the sort of use cases and how things are evolving, and the space for 5G program in telecommunications and the related technology support opportunities that you have at fingertips. So, Tony.
Sure. Thank you very much, and hello everybody. Good evening. I hope you're well, taking care of yourself, happy and healthy during this lockdown, which is far too long, but also perhaps which emphasizes, I'm calling from London today in the UK, and perhaps this lockdown emphasizes even more the need for communication and connectivity everywhere. And perhaps this in itself is a good reason for ESA to get involved and to make sure that with the coming of 5G, we can help improve everyday life for everybody on Earth. This in itself would be a very noble goal for this program. But I'm going to tell you a little bit about the Space for 5G program, which is the program I am leading and coordinating in the agency with respect to all activity about telecommunications and the integration between satellite and 5G telecommunications. So in the next slide, we can see one of the slogan we like to use, expand 5G space. Let me tell you a little bit for the origin of this program. We are witnessing a digitalization of industry and society. Everything is getting digitalized. We talk about smart cities. We talk about smart airports, smart ports, smart cars. Everything is getting smart. But in order for everything to get smart and to enable the smartness of our world, which improves both the industry and the society by and large, we need connectivity. We need a connectivity fabric which underpins every single element of this digital society. And that's where 5G comes in. 5G promises to be the connectivity fabric which enables the global digitalization. And that's very good. That this is where ESA, I think, we have a very important role to play. In order to expand 5G space, we aim at complementing the terrestrial 5G deployment so that the entire globe, the entire Earth can benefit from this global 5G seamless connectivity for the benefit of everybody. So what we're trying to advocate with this program really is what I call a triple win for society. It's a win for the space industry, because obviously the space industry has a great opportunity to embrace the terrestrial 5G technology and work alongside each other to expand that. It's a win for the terrestrial 5G community, because satellite can go and fill in those gaps of 5G coverage, or perhaps add those attributes of resilience, ubiquity, and security that 5G demands. And finally, is a win for every one of us, because with that global 5G connectivity will enable the industry 4.0 and will enable all of us to be more connected and to benefit from this connectivity fabric that everybody has. So that's kind of the reasons we are behind it, but that's not only it. There is also a very strong economic element that 5G brings along. So in the next slide, we can see what I call a very brief glimpse of what I call the 5G economy. If you look from a macroeconomic point of view, the 5G economy is absolutely compelling. The macroeconomic impact of 5G is staggering. With this global connectivity, reputable market research talk about a 5G economic impact in the order of more than $10 trillion by 2035. This is if you consider not only the economy of deploying 5G base station and 5G satellite-enabled terminals, but actually the impact that 5G has on the downstream economy, on all the vertical markets which are enabled by 5G. So $13 trillion is a huge, staggering amount. And our estimate is that our analysis shows that of that element, the satellite-derived economic impact by itself is in the order of $500 billion. So there's a very, very strong economic rationale and reasoning behind this need for global seamless connectivity and the need to integrate space assets, whether it's satellite telecommunication, navigation, or Earth observation, being part of this global connectivity which enables the 5G economy. So the idea is not only very strongly from the humanitarian point of view in connectivity and help improving everyday life, but also to enable an inclusive, sustainable, and competitive global economy. And that's one of the reasons we believe at the Space Agency that we have a unique opportunity to intervene and to make sure that this telecommunication, navigation, terrestrial, and satellite sectors get together to enable and unleash this economy. So in the next slide, we start seeing what does it mean in terms of technology? And my previous colleagues already talked about some of the elements of this. But based on this strong on the fact that 5G and satellite 5G has a very strong economic and humanitarian impact, we have put in place a program which helps the space industry, the European Canadian space industry, to develop the required technology, systems, application, and services which make use of this global connectivity. And ultimately, what we want to do, if you observe these pictures, on the top left, there is a satellite, and the bottom right, there is a 5G mast. So what we want to do is to help build bridges between the terrestrial telecommunication infrastructure sector and the space sector. Build bridges to build better solutions together. So we have put in place a number of financial supporting elements, what we call 5G essential building blocks. We believe that as ESA, we must help industry yourselves to develop a technical solution in the integrated 5G terrestrial and satellite world. There are building blocks there, which are things like building 5G satellite core networks, as Stefano was mentioning before, integrating terrestrial 5G core networks with satellite networks. Build satellite proof of concept missions, which showcase the potential technical and economic impact of delivering a satellite-based 5G solution. Last but not least, work on standardization. And again, Stefano explained very much the effort that collectively in the agency we are putting to make sure that the 5G standardization is a family of standards which includes terrestrial and non-terrestrial, in this case, space assets of telecommunication and navigation. And finally, we are putting a lot of emphasis in over-the-air demonstration and 5G hubs, something I'll come back towards the end of the presentation to see what pragmatic actions we are taking to demonstrate the impact that space can have on 5G. So all these building blocks are technology developments, which we have issued some invitation to tender, open tender, where we provide a high degree of funding to help the industry to develop these missing technology blocks. And if you go to the next slide, the counter side of the story is that we are very much focusing on the downstream applications as well. So if we now start to go down a little bit into the vertical markets that are addressed by space and 5G, we can see that depending on the industry sector we analyze, space for 5G can have an impact pretty much in all the vertical 5G markets and sectors identified. Here we list some of the most promising sectors where we believe that the integration of space assets with terrestrial 5G can benefit these sectors as a whole. First, I want to mention telemedicine and digital health and remote health. This the medical industry is undergoing a transformation, again, part of this digitalization. So there is digital health, which especially telemedicine and moving the care of the patients from the hospital to the home and to the local center, decentralizing hospital care. So all of this requires strong connectivity, especially in rural areas where perhaps 5G and perhaps even 4G might be a challenge to reach. Developing, making sure that the hospitals are not so flooded, overgrown by people, but perhaps trying to prevent and prevent illness from the outset by reducing the number of people in the hospital. So this is something that the provision of satellite telecommunication can do in order to help to provide the doctor and help them to deliver care remotely. But also tele-education and remote schooling. This is something very, very topical today. Again, this cannot be made available without seamless connectivity. That's where this some of the solution we are helping, for example, companies in Africa to deliver remote education for African schools in remote villages and rural centers. But perhaps now becomes more of a global need to provide this enough bandwidth capability specifically for teleeducation. And going on, there's a lot of transportation, and I have a couple of slides of transport. Transport is one perhaps of the most evident sectors where satellite is important, certainly in the transport for aviation and transport for maritime. This together with autonomy, we see, we mentioned already autonomous car, connected autonomous vehicles, but also we talk a lot about maritime autonomous ships and unmanned air mobility, unmanned air vehicles. So there is a lot of automation and digitalization in the transport industry, which blended with a set of different telecommunication can help unleash all kind of new vertical markets within the transport sectors. Last but not least, agriculture and energy are two very, very important industry where by nature, by the location of this or this deployment, satellite can play an important role. So we have a number of application support mechanisms to support application and service provider to develop their product and services which make use of space and non-space telecommunication to unleash, enable the smart cities and smart rural areas and smart ports and smart airports of the future. And I'll give you a couple of examples remaining on transport. Perhaps on the next slide, I want to give you a quick glimpse on the connected autonomous vehicle market. This is a booming market and perhaps is one of the most talked about in terms of 5G verticals. And it is true that it's a very, very promising market. The convergence of electrical vehicles, digitalization of information, and the autonomy, the driverless car or the autonomous vehicle. So the autonomy, electrification, and digitalization are perhaps best coming together in the connected autonomous vehicle market. The car is becoming a data center. It's a collector of different type of sensor, environmental data, road condition data, weather, traffic condition, and so on, so that this data can be transferred back to the network, to the cloud, and this data could be monetized. Equally, on the other side, cars can be enabled remotely to drive, either remote control or autonomously eventually, but only thanks to the connectivity. There is a set of new protocols, V2X, vehicle to everything, being devised, being defined, standardized, in order to enable the car to talk to everything around it. So whether the car talk to the electric grid in order to optimize the electric charging of the car, and the car can become therefore storage of energy, which can then be shared back to the grid and monetized, or whether the car talks to the network, vehicle to network communication, or whether the car talks to the infrastructure, vehicle to infrastructure, where the car is alerted by perhaps traffic situation, situational awareness. All of this need continuous, reliable, and secure communication. And that's where satellite becomes very important in terms of providing the infrastructure globally across different environments. On the bottom left of this slide, I list what we believe are the most suitable use case cluster where satellite can play an important role. And things like vehicle monitoring, remote monitoring, or broadcast of high definition maps, navigation maps to the car. Software over-the-air upgrades is another area where satellite can be very efficient in delivering new software updates for the car. As I mentioned, situation awareness and teleoperation is very, very important. All of this has to do with what we call Internet of Things, so machine-to-machine communication. So this is machine-to-machine. A lot of the expected communications and data traffic in this market is expected to come from machine to machine. So there's a set of all the V2X protocols are all defined to for machines to talk to each other and for all machines around the car to talk to the car and vice versa. Equally important, of course, is the infotainment entertainment market, where actually we're talking to this time to person and people. There is a lot of technology development in that area. We talked about 3D car cockpits, for example, where we had 3D and virtual reality information coming to the driver, where either with head-up displays or 3D displays, surrounding information and complementary information gets blended and presented to the driver and to the passengers in the car in a way to enhance their experience, enhance their safety, and provide the required level of perhaps alertness, situation awareness to improve the safety of drive, or perhaps HoloLens or virtual reality experience, a headset for the passengers back in the car, perhaps where they can stream their own Netflix film, and maybe in a 3D headset style. So there is a lot of technology, blends of virtual reality, augmented reality, which requires a large amount of data transfer, communication transfer to and from the car. All of this is something that we see. We are working with companies that developing solutions and testing some of these solutions together with the companies or with the OEM car manufacturers or with the solution service provider. And this is something we'd like to support more and invite the company to provide proposals and solutions where we can be part of enabling these new markets. Perhaps on the next slide, and maybe moving a little bit faster, I want to show the similar trends we see in the maritime sectors. So again, remaining transport sector, smart ports, and maritime autonomous ships is something that we see, we are working with, and we want to support even more. In this respect, we are about to launch an announcement of opportunity in February for call for proposal to develop products and services and applications enabling the smart and uncrewed shipping market. The themes we are considering are on the, not exclusively, but indicative are on the right-hand side of this slide. So we want to enable the shipping 4.0, as we mentioned, digitalization of the maritime shipping industry, the monitoring of coastal areas where the connectivity and communication is always a challenge, and the blends between ship-to-shore communication, satellite communication, terrestrial, different type of communication is very, very important. So integrating a communication seamless connectivity solution to support this type of services. Along with that is maritime surveillance, something which is very close to our heart, to provide maritime safety services and maritime surveillance in all sorts of public safety solutions. And last but not least, take care of the environment. So environmental sustainability and how the new evolving digitalization of smart ship sector can help, or at least not hinder, but rather help the environmental sustainability at sea, of seas and coastal areas. So this is something we're very much looking forward to. It's a joint initiative between the Telecommunication, the Navigation Directorate. It's focused on solutions for smart shipping, which make use of 5G and or position navigation timing solution. And it covers the whole range of activities from technology developments, product developments, ultimately focus on demonstration of specific applications in this sector. This is just an example of the type of call for proposal, type of initiatives where ESA is supporting industry in developing these solutions. We move to the next slide. And this is the last.
Antonio, can I ask you to be a bit quick, because we won't have time for questions otherwise?
Yeah, of course.
Sorry for the interruption.
That's absolutely fine. This is the last things where not only we look about transport, but also we look at things like cultural heritage and working with municipalities like the city of Roma. in Italy, Torino, L'Aquila, and Abruzzo. This is an ongoing set of activities. There's an open announcement of opportunity.
Okay, we appear to have lost Antonio. So he's basically finished his presentation anyway. So apologies for that. Hopefully we've still got Stefano and Florin online. Well, before we go on, thanks Stefano for the presentation. Hopefully we can get you back at some point. The next part, basically from now until the end, is questions to the speaker. I would encourage the audience also to submit questions. If you don't want to have your name or your organization associated with the questions, we can ask the questions anonymously as well. So please take this opportunity to ask all the burning questions you've been thinking about for all of your life on fifth generation technology developments. In the meantime, just a couple of questions on the basis of the material that you are presenting. I suggest that we go in the order of Stefano, Florin, and then Antonio, if we can get Antonio back. So firstly, given the target audience here is the Twin Cities, considering the changes occurring now and over the next few years in from things like climate change, resource utilization, etc. What do you think are the real priority interests that we should be addressing with these technologies with respect to the planning and management of city and urban areas, and what are the sort of technical developments that we should be focusing on to address these opportunities? Please, if you could start, Stefano.
Thank you, Gordon. Yeah, I will cover at least from the standardization perspective point of view. So, of course, as I mentioned, but also all of us mentioned during our presentation, 5G has some keywords, and surely smart cities, green communication are really important element of this process of defining the future 5G network. So certainly from this point of view, the 3GPP standardization is looking very carefully, and satellite now is part of that, to help, let's say, to improve the quality of life in our let's call it next generation city, where autonomous driving, augmented reality are really key feature and really key enabler also to reduce, let's say, CO2 emission, and also to help our day-by-day life in our city. So from the standard point of view, these elements are really taking into account and are strong keyword for all terrestrial and satellite stakeholders. Thank you.
Okay, Florin, your thoughts?
From my side, I would just like to remind quickly to everyone that 5G involves deployment of very, very dense networks. There's different types of cell, from very large to the very small ones, like femtocells and indoor and so on. And I can imagine that there's there's need for a lot of energy to power up these networks. And maybe that's not the most environmentally friendly approach. So I think in the future, energy efficiency of these networks should take a central role.
Okay. Antonio, did you hear the question, or do I need to repeat it?
I'm afraid I lost the. I wasn't on 5G. I don't have 5G, and I lost the connection. Maybe you could repeat the question, please.
Yeah. Okay. Yeah. This session is an advert for 5G in itself, I suppose. So we're just saying, with the developments over the next few years for the target audience, the Twin City, so in areas like urban planning, urban management, etc. Where do you see the priority needs for these sorts of capabilities, what the priority uses, and what are the priority developments that we really should be focusing on over the short term to address these?
Okay, thank you, Gordon. If I understand the question, yes, I think that the digital twin and smart cities, I think from the discussion we've been having so far, it's obvious that it's important to put a lot of emphasis in the planning stage and optimizing the design of smart city, which takes into account environmental friendly solutions where the connectivity is planned in an optimized way. As Florin was saying, it doesn't mean deploying millions or billions of 5G base stations everywhere, for example, but perhaps planning intelligently so that there is a good blend of connectivity designed to solve the smart city needs in a friendly environment. I think that's very important, that the city planners get together with technology architects, technology solution providers, if you like, to plan cities according to the requirement for the future, and make sure that this connectivity fabric I was talking about is planned and available in the most cost efficient and technical and green sustainable way. Whether that means studying the blending between indoor and outdoor communication, satellite and terrestrial communication, that's some of the trade-offs which I think needs to be put together. The good thing is that we work on the standardization side to make sure that all these trade-offs will be available, the technology will be behind to support the needs of future cities and smart cities.
Okay, we have a question from the audience I would like to go to next. So same order of answers, please. And the question is, can 5G accelerate the bridging of the digital divide and connect more people to the internet in terms of cost, ease of implementation and efficiency?
Yes, thank you, Nicholas, from this question. Of course, yes, from our perspective, from let's say the SATCOM point of view, this is one of the pushing element, or the, let's say, the motivation behind, let's say, our presence in 5G. I think we are very well aware that, in fact, still today in 2020, 2021, digital divide is still an issue in also in the so-called Western country, like also all Europe coverage or US coverage. So in general, satellite can really bring the so-called extra component to reach underserved area. Of course, as I mentioned, also from the standard point of view, the data rate could be slightly different at the beginning. Of course, the technology from satellite should try also to push a bit faster to close the gap. But definitely, satellite component will try to reduce as much as possible this digital divide and to enabling, let's say, fair quality among all of us all over the world. Thank you.
Thanks, Florin.
Yes, I do believe 5G can accelerate and bridge this gap between the people that are connected and not connected, as long as a satellite component is introduced. Otherwise, I don't see it very easily to deploy large networks all over the world. And just as a statistics, I've been recently reading that about 40% of the globe population still does not have access to mobile internet connectivity. So that's a huge addressable market for satellite and 5G in general.
Antonio?
Yes, absolutely. I think it's been said, absolutely 5G will help bridge in the digital divide, but 5G in the wider sense, as Florin said, the seamless integration of terrestrial and satellite 5G will bridge the digital divide. And that's exactly the program we put in place to help bridge the digital divide globally for everybody at any time. Yes, absolutely.
Okay. We have another question from the audience. So I'll just read it. Can we expect phones connected to satellites as backup, or being able to call 112 via satellite from 5G phones anytime soon, like the next 5 years? So, Stefano?
Yes, of course, this could be really a primary type of service via satellite for our, let's say, smartphone, for a seamless connection between terrestrial and satellite. Actually, as I mentioned, during the time frame, the standard will be available in 1 year or so. So giving the time to our, let's say, telecom industries, both terrestrial and satellite, to implement this modification, I would say that certainly in 2-3 years' time, I would say that E911 or E112 in Europe will be certainly a use case, very important, and the global coverage of satellite and the required data rate are fully compatible with this feature. Certainly, sure.
Florian?
Yeah, I would just suggest to the author of this question to do a quick Google search and see what Vodafone is attempting to do with a startup in US. They have exactly this idea to connect actual smartphones without changes to the hardware to satellite. I don't think it's a standard-based solution. I think it's something proprietary, but still interesting to look into.
Mm-hmm. Okay. Antonio, very quickly, because we've got a third question that I'd like to ask.
Yeah, sure. I think that's where the industry is going. And yes, I think we are working with the operators which are very keen and interested in bringing direct access from satellite to mobile phones. And we will see that happen in the next few years.
Okay, the third question I'd like to get in before the end is, what are the models and procedure to collaborate with ESA launching some demos of 5G over satellite? And also, since we've not got a lot of time, where can people get more information on this? Thanks.
I think Antonio could really try to tackle this one, because I think it was part of this key element in this presentation. So Antonio.
Yeah, okay. Yeah, for sure. I think we have a lot of funds available. The Space for 5G program is over 200 million euros to develop technology, solution, application, and services. I think the best thing would be to get in touch with us at an email called 5g@esa.int. So it's the digit 5 followed by the letter G, 5g@esa.int. We can provide more information. But also you can Google ESA Space for 5G, business solution 5G, navigation 5G at ESA, and you access to our channel. But perhaps 5g@esa.int is the first protocol, and they would be able to point out the various schemes, the various process, the various application procedures, and everything else.
Okay, and do people have to be companies, or what sort of organizations can you work with?
Yeah, we work with companies. We work with small and medium enterprise, startup companies, large companies, development company, application service providers, technology providers. But yes, you must be a company and not individual, and you must be one of the European member states or Canada, so one of 22 member state countries of ESA, in order to benefit from ESA funding.
Okay. So I'm conscious of the time. We're going to be shut off within the next less than 1 minute. So I'd just like to wrap up the whole session and say thank you to the speakers. So thank you, Stefano, Florian, Antonio, for shedding light on what you're up to and the opportunities that it's creating. Thank you to the audience for the interesting questions. Thank you to the Genus team for sorting out all the infrastructure and making things run particularly smoothly, even when Antonio was overrunning. Yeah. So, and if you require any other information, please get in touch with us at ESA, or look at the connections that Antonio was talking about in his last answer. So, I'll close the session here. Thank you very much, and have a nice evening, everybody.
Thank you for the invitation. Bye bye.
Bye. Bye.